we're using that old book, and remember I did 7-1, 7-2, 7-3. Well, we are back in our new book, our current book, but we're doing 7-3 in there also. So we're doing 7-3 book. So at the top, you might want to write that these are the book from the book because your other notes say 7-3 also. So we're topic 7, section 3, triangle similarity. So we have a picture here. I'm not having you fill in any of the pictures, but we see that angle A and angle D are congruent.
Yeah.
And we see the angle B and angle E are congruent. Okay. Well, if two angles in a triangle are congruent, what does the other one have to be? Congruent. Okay. So this just says this is the angle similarity theorem. And we will say, every time you say they're similar, you have to say AA, and what's the symbol mean? Similar. So A stands for angle, so it's the angle similarity theorem. Okay? So, yeah, same thing. Okay, so if two, let me get my pen and move this to this side. So if two angles of one triangle are congruent to two angles of the other triangle, so you should be starting to write 2. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Now, we are not saying the triangles are congruent, okay? We are saying that they are similar because I can have the same angles and stretch them out and make all different triangles, okay? So they're only similar, they're not congruent. And when you say they're similar, then you're going to put AA similar, okay? So you're going to justify everything like we did with side, angle, side, when we did congruent triangles. The next one we have is side similarity theorem. And so we have side, similar. So if you're highlighting, that's something you want to highlight, right? Okay. It says if two corresponding sides of two triangles are proportional, then the triangles are similar. So we have our proportionality statement here, correct? So I have AB is corresponds to what?
DE.
DE. BC corresponds to EF.
Yeah.
AC corresponds to DF.
Yeah.
Okay? Do you see how one triangle is on the top and one triangle is on the bottom? Could I reciprocate all of those if I wanted to?
Yeah.
Yes. Okay, if whatever I'm looking for, remember we always want to try to get in the numerator because it's easier to do the math, right? But you don't have to. And we just have triangle ABC is similar to triangle DEF. Then lastly, we have a side angle side similarity theorem, and that is SAS similarity. Okay, so I guess we'll look at the picture. So SAS means side angle side, yes? Yes. So from the picture, you see that B and E are congruent. Angle B and E are congruent. So the sides that have to be proportional are AB to DE and BC to EF. Okay, they have to be the two sides that make the congruent angle. That would make sense? Does that make sense? Okay, so if any angle of one triangle is congruent to an angle of a second triangle, and the sides, and this is important that it's sides that are included, that include the two angles, are proportional. Again, not congruent, proportional. Then the two triangles are similar. Okay, and the only difference between this and when we did congruent triangles is the sides had to be congruent, right? Now the sides just have to be proportional.
So is our homework a worksheet, or is it from the book?
We're doing a worksheet today. Okay, are triangle A, B, C, and D, E, F similar? You cannot just tell me yes. You have to show me your math, and if you say yes, then you have to tell which one. You have to use your 3 theorems on the front. So we have to use angle-angle similarity, side-side-side similarity, or side-angle-side similarity. Okay? So when I see these, do they have any angles here?
No.
No.
They're just
But I do
numbers.
have all the sides. So if it is, it's going to be side-side-side similarity, right? Okay, so how do I check if they're proportional? I set up my, set up your proportions, right? I like to put the decimals in the numerator. Anybody else?
Yeah.
Okay, so I'm just going to put my decimals in the numerator. So I'm going to put 7.5 equal to 4.5 equal to 6. Now, you need to match these. The longest side goes with the longest side, correct?
Yeah.
So 7.5 goes with what? 5. 4.5 goes to?
3.
3?
Yeah.
Oh, because it's shortest. Sorry.
That's 4.
And 4. I normally write them in biggest to smallest also, just to keep my brain straight, but do I have to? No.
I thought you were gonna call me wrong for that.
No.
Saying 3. I was like, oh.
Now I need to reduce, correct?
Yeah.
Okay. 5 goes into 75, doesn't it?
Yeah.
Yeah? Okay. So I am going to put a 1 in the denominator, right? And, oh, but I can't make it 75. I have to make it 75, so I have to make it 50, don't I? Because we want to, ooh. My eraser was way too big, wasn't it? Over
That's 4.5.
over 3.
And
7.5 over 5, right?
Yeah.
Okay, so I have to make this 50, so I can make that 75, right? I have to make this 30, so I can make that 45.
Wait.
And
what are you doing?
I'm getting rid of the decimal because I want a fraction. I want a proportion when I'm done. I can't have a decimal in a fraction, can I? No, because a decimal is a fraction, so it's like a fraction in a fraction, and then it's a lot more work. So now I have to reduce. What goes in 75 and 50? 5. Probably something bigger.
25.
25, right? Okay, 25 goes into 75 how many times? 3. And 50, 2. So they all better reduce to 3 halves, right?
Mm-hmm.
Yeah? So we divided this one by 25. Let's go clear over here. 6 and 4. What's it reduced to?
3, 2.
3 over 2. Now, if I got the second one wasn't 3 over 2, I could stop, right? But maybe I should check, and then if I got the 2 ends, then maybe go back and check my math, right? But if I get one that's not proportional, we're done. Okay, so what goes into 45 and 30?
15.
15. Thinking time. 15 goes into 45 how many times?
3.
3. And it goes into 30? 2. So, are they similar?
Yeah.
Yes. By what?
By
by side, 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 similarity.